Alright guys, 5-6 is about inequalities in triangles. What they have here are a bunch of different theorems. Copy them down just so you have them, 510, 511, and 512. But what they're saying is basically that the largest angle is opposite the largest side. And the smallest angle is opposite the smallest side, and vice versa. The smallest side is opposite the smallest angle, and the largest side is opposite the largest angle. So one way or the other, that's all these theorems pretty much say. Okay, and then triangle inequality theorem, the last one down there, theorem 512, states that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. If it's not a triangle. So basically, two sides have to add up to be more than the third side. So if we look at problem 3 here, it says write the sides of triangle TUV in order from shortest to longest. So if I take a look at triangle TUV here, I have 58 degrees, I have 62 degrees. I've got to go ahead and tell me what angle T is. So I'm going to take 180 minus 58 minus 62, and this is going to be 60 degrees. Okay? So now to write the sides of it from shortest to longest, let's find the shortest side first. Well, my shortest angle is going to be U. That's the smallest angle right here. Well, what side is opposite U? TV. Okay, so TV is the shortest side. Okay, what's next? 60 degrees with angle T. What's opposite angle T? I'll give you a hint. It's the one that doesn't include T in it, so it would be UV. And then the longest side would be opposite 62, or angle V, which would be TU. Okay, problem 4 says, can the triangle have sides with the given lengths? So in other words, are the two sides greater than the third? So you're going to set up three equalities. 3 plus 7, is that greater than 8? Is 3 plus 8 greater than 7? And is 7 plus 8 greater than 3? Well, you just add them. Is 10 greater than 8? Yep. Is 11 greater than 7? Yep. And is 15 greater than 3? Yep. Okay, so we're good on all three, so yes, this can be a triangle. What about 5, 10, and 15? Well, again, set them up. 5 plus 10, is it greater than 15? Is 5 plus 15 greater than 10? And is 10 plus 15 greater than 5? Okay, well, 5 plus 10 is 15. Is 15 greater than 15? No. It is not greater than 15. So no, it's not equal to, it's greater than. It has to be greater than. Okay? So that leads us to problem 5, which talks about two sides of a triangle are 5 feet and 10 feet. What is the range of possible lengths for the third side? So again, if our sides are 5, 8, and x, what could that third side be? Well, I'm going to set up three inequalities. 5 plus 8 has to be bigger than x. 5 plus x has to be bigger than 8, and 8 plus x has to be bigger than 5. And now you solve. 5 plus 8 is 13. 13 has to be bigger than x. Okay, subtract 5. I get x has to be greater than 3. And subtract 8, I get x has to be bigger than negative 3. Well, this doesn't make sense. An angle can't be, or sorry, a side length can't be negative 3. You can't have a negative side length. So the only two that matter are this right here. So if I'm writing this in a possible range, I'm going to take the smallest, I'm going to put x in the middle, put the biggest here, and always face the arrows left. So in other words, 3 is less than x, which is less than 13. And that's how I'm going to write my range of possible lengths. So anywhere between 3 and 13, x can lie. And that will be your possible side.